presentation. Stormrake's passionate about education and bringing you the latest news. And now we are going to be discussing energy and how it applies to Bitcoin mining. My name is Michael Milmeister. I'm the founder and commercial director of Stormrake. It's a full-service cryptocurrency brokerage. My background prior to crypto was in the energy business as well, and that was as head of energy at Vocus, better known as Dodo Power and Gas. And that is a gas and electricity provider back in the day. Today, I have with me Gary Viviers, who has an incredible wealth of experience in the energy world, trading across a bunch of different types of energy across different countries and companies. And he's going to join us today because he's got some interesting takes on how energy applies to Bitcoin mining. So, Gary, over to you. Thank you for joining us. And
no worries.
Yeah, how are you feeling?
Yeah, good. Thanks, Michael. Thanks for the time. And yeah, sounds interesting. I'll just have to see if everyone else thinks what I have to say is interesting, but I'm happy to have a chat.
We'll check out the comments afterwards.
Yeah, okay.
Gary, could you tell us a little bit about your background and the kind of companies that you've worked at and what experience you've had?
Yeah, sure. I guess for a lot of people that watch this, I definitely come from a more traditional background. My background's been mostly in proprietary trading, mostly in energy, sort of starting with electricity, Australian electricity specifically, and then moving into bulk commodities, things like coal, iron ore, steel, coking coal, and various different takes on that. Carbon, participants in the initial CDM scheme, which is one of the precursors of global carbon trading systems, European emissions trading, and also obviously the peripheral things like gas and oil. Companies I've worked at are companies like BP Oil, where we set up an electricity trading desk and also a carbon desk, and also Merrill Lynch, and Noble Commodities, which is a big commodities trader globally, in various jurisdictions. I lived in obviously in Sydney, Singapore, and London a couple of times each. Yeah, I mean, I think I've traded pretty much everything in the bulk commodity space, and hence the conversations we've had, and because of my sort of experience, which is much more traditional mining, normal moving sand around, see the sort of similarities between that and sort of Bitcoin world.
So how is it that someone obviously from traditional markets and in the energy space came across Bitcoin, and what is your current role at the moment at RMHedge?
Well, the reason how I came across it was, I've always kind of been interested in it. I've never been a participant, unfortunately. I wish I'd, bought some at 50 cents, but I didn't. Obviously, for a few years ago, everybody was talking Bitcoin when it started going over 10,000. You couldn't get into a taxi without somebody discussing Bitcoin with you. It seems like that's softened now, and obviously people have the point of view of liking to see it, have a bit of fall from grace from a price perspective. But the funny thing is, it's still double what it was when everyone was talking about it. I think people conveniently forget about that. But
the mood is very different when it first hit 20,000, and when it hit 20,000 on the way down.
That's absolutely
different, even though it's the same exact price point.
Yeah, it's like a stock market at the moment. The stock market goes down 1%. Everyone calls it, bloodbath, but everyone forgets that it's like, 5 times what it was just a few years ago. So how I sort of what I do at RMHedge and what I did at Pacific Hydro before this, which is a renewable energy company, was basically trading and optimizing, how they use their generation, how they sell to customers, most efficiently, and how they hedge their position, which is difficult when you're dealing with wind and solar, which is intermittent in its nature. So you never know really if it's going to be there when you need it. And the times when it's not there may also be a time that coincides with very high demand, which means that just your buyers are going to want it. So you can have sort of a double pain effect if you get it wrong. So yeah, that's what I'm currently doing.
Yeah, awesome. And last time we spoke, obviously, you had some really interesting insights into the Bitcoin mining world, considering you're coming from the energy side of things.
Yeah.
And, some of those were around, well, the whole business model and how traditional mining is kind of similar to Bitcoin mining. And Bitcoin mining is a term that not a lot of people actually like, because they don't think Bitcoin mining describes what it actually is quite well. But interestingly, you thought that it is an appropriate term. So do you want to comment on that?
Expand on that. Yeah, I mean, look, I'm sure people are going to have different takes on this, right? And I guess where I'm coming from is more from traditional mining background. So I'm obviously going to see it from that perspective. Whereas somebody who's spent their whole life in coding and is not going to understand that or see it that way. Why I think it is similar is because the simple things, like for instance, if you look at your sort of short run marginal cost, which is pretty much your fuel input costs, what it costs you to get every ton of whatever it is that you're mining out of the ground. It's very similar to the sort of economics that go into Bitcoin from a point of view that your major input, once you've built everything, once you have your operation up and running, which is sunk costs in essence, is your short-term marginal cost, which is pretty much electricity. There's a few other things that come into that. You need some IT assistance and that kind of thing. But really, if you have your own operation running, your major cost is electricity. And for a miner, that same thing plays out, because with a miner, their biggest cost is, for instance, might be diesel. If they're running mostly, diesel units on diesel miners on their sites, like excavators, bulldozers, etc., then diesel is going to be your highest cost. It could be up to 80%. So they have the same thing there. The other thing, obviously, that I think is similar is in terms of where you sit in the efficiency. So if you're a very expensive miner, and let's say it's costing you whatever it is, $100 to get whatever it is out the ground, and that thing drops to being worth $80, well, at some point you're going to have to think about turning off. And I think it's exactly the same situation with Bitcoin. If you're someone who's got 6, 7, 8, 9, 10 cents a kilowatt hour, and you're mining at that price, then especially with Bitcoin having fallen dramatically, and also with the difficulty increasing all the time, same as what a mine is. The difficulty increasing with Bitcoin is the same as a mine that has been operating for a while. That strip ratio, which means the amount of dirt they have to move, the amount of tons of dirt they have to move to get hold of the ton that they need. So it might be 10 to 1 or 20 to 1, at some mines. The worse that gets, the lower down you go in terms of where you sit in the cost stack.
Absolutely, and it's a globally competitive industry. You're competing with every other country in the world, where some of them may have very low energy costs for whatever reason. You're competing against a world where access to becoming a miner is permissionless, so anyone can start. And you're also competing with people that are even mining below cost, because they thought it was going to be nice and easy, and they ended up losing money, but they were in the system for a period of time competing against you. So you have to be globally extremely efficient, which is very similar to normal mining, where you have periods of time where the price of what it is that you're mining can actually be below cost. And then it's a race to see who's going to get forced out of the system the earliest, and then everything
it becomes a war of attrition at that point. Whoever's left standing is the winner. It depends how much it costs you to stay standing. That's really the problem. And the same thing happens with miners. Is if it's becoming too expensive for you to mine per ton, what the general sort of thinking will be is, okay, we'll increase the amount of tons that you're mining, because obviously the more tons, you start to get more opportunities of scale by the fact that you're dropping your average cost, because there's twice as many tons, for argument's sake. And I think the same thing happens where people start going, okay, well, we just need to mine harder. And I think that's sort of, in traditional mining markets, that usually is a sort of precursor for recovery. You tend to see a much bigger drop just before things start to get better, because all those people that are still running as hard as they can, trying to stay, what we used to call, above water, they are running even harder. So more and more tons get produced. The price gets even weaker, up until the point that nobody can handle it anymore, because you become the agent of your own destruction by running harder and harder. You make the price get worse.
Exactly the same in oil. Sometimes you get those sort of situations. The other part I wanted to ask you, you've come across some situations where Bitcoin is sitting behind the meter, Bitcoin mining is sitting behind the meter, exploiting energy that may not be able to get out to the grid, or may at least be cheaper than accessing it directly from the grid. Can you tell us a little bit about that and what how that actually functions?
Yeah, I mean, how that all sort of began is, a company I think I don't mind mentioning is Archon Energy. They were looking at setting up in Australia. They're actually more focused on Finland at the moment. But what we discussed with them is, a very high level, we started talking about, well, can we connect a Bitcoin operation to renewable energy? And in Australia, I'm sure there's expertise outside of Australia that are doing this, but in Australia, there just isn't many people who know how to do that. The electrical engineering teams in Australia, while they're very good at what they do, this is something totally new for them. So it's an exercise in everyone figuring out what's going on. How do you do this from the get-go? And so what we were looking at is, how do we put behind the meter Bitcoin operations at a renewable energy site, in this case, wind. And what we found is, obviously, it's not a case of you just dragging up a 40-foot container and plugging it into a wall socket. You've got to get, and we didn't know this, to be honest. I thought it was probably that easy. There's probably a wall socket somewhere in the switch yard, and you just plug it in. That's not what happens. You basically have to ramp down. Exactly. Well, we did discuss if we could buy one that size from Alibaba somewhere. Maybe it exists, but we basically got to the point of seeing that to ramp down a 4,000 volt wind farm to 230 volt wall sockets, it takes firstly a lot of engineering. It takes a lot of money also, because it's very expensive. These things are all bespoke. You can't go buy these things at your local electrical shop. And also it's exercise in figuring it out. So once we did figure all of that out, we knew what the costs are going to look like. It still made sense. In Australia now, it's probably not going to happen for a bit now, just because the electricity prices are so high due to the energy crisis that we've seen everywhere.
It won't happen in Germany either.
I doubt it. I'm pretty sure that they would be probably turning off. I don't know. Look, I don't know. Like, different countries do different things, right? But I think it'd be very hard to justify at the moment, given their situation. Russia might have quite a lot of extra energy, though. Maybe we should go talk to them if you want to put it there. But what we found is that then behind the meter, a lot of benefits, because you end up cutting back on a lot of network costs, which add a lot to your costs in Australia. We also found that what's interesting about it is that a big problem for a wind farm and a solar farm is that the harder you are generating, if the whole state, if the whole country is very windy, you're going to see a very low electricity price, because there's a lot of wind farms running. And what that creates is a thing called
not just
basis
low,
risk.
potentially negative.
Exactly. And Australia can go to minus $1,000. So a year ago, we were sitting at 30% of spot prices every 5 minutes being negative prices. That's changed now because of energy, but the same dynamics are still in place. And what we found is that, by definition, if you're running a wind farm that you expose to the spot market, the harder it runs, the worse it is for you, which is very ridiculous, right? It's basically, the prices is inversely correlated to the wind. So what we found is that we need a way to not have that situation play out. And what we found when we did all the analysis is that having a Bitcoin operation at the site behind the meter is pretty much identical from a financial perspective. That I think it's probably, at that point, was definitely more lucrative to put a Bitcoin in place instead of the battery charging. But it's exactly the same situation that plays out, because instead of storing chemical energy that you then later dispatch back into the grid when the price is better, in this case, what you're doing is you're storing financial energy, in essence, a financial benefit, and you can then decide how you use that. You can sell it into the Bitcoin market, or you can hold it, or you can do whatever you want with it. With a battery, you don't really have that choice. Once you've charged it, there's certain dynamics that you have to play to.
Well, there's a significant loss as well, right? So for large scale batteries, it was quoted in order of like 10% a day of losses. I don't know if they've gotten better, but it can be quite significant either way.
There's a lot of factors that you have to consider. It's how quickly you can charge it, how quickly you can discharge it. There's also other factors that come into place with the network and the FCAS and the frequency controls and that kind of stuff. So it's not quite that straightforward. Where in many ways, a Bitcoin operation, the other challenge that you have with Bitcoin attached to a wind farm is obviously that sometimes there isn't going to be no wind, and something a Bitcoin operation wants to run as hard as it can, if it can, 100% of the time for the whole year. And in the case of wind, the sort of rule of thumb is that you can have about 30% of your capacity. And to be honest, sometimes you have nothing, and sometimes you have 100%, which you never know what it's going to be.
Just not good enough for someone trying to get the most out of their equipment that is facing equipment depreciation in a very fast rate. And that's because new equipment is being produced all the time. That's the next generation superior. So if you're looking at hash rate and you've bought your equipment at a point in time, that hash rate is constantly being killed by new technology that's coming out. As new technology comes out, that difficulty adjustment kicks in, and you're just generating less Bitcoin as a proportion with your old equipment. So you want to make the most of it as you go, and you certainly don't want it on only 30% of the time. You want it running all the time, flat chat.
So the way we solved that is basically to have two connections, one to the renewable asset and another one to the network, where you can be buying from the grid. And in Australia, where Australia is becoming very renewable, there's a lot of renewable energy running, and besides that fact, you can also buy all the the enviro certificates that help to green the network. So we solved it by saying that there were two connections. So you would always be, if you needed to augment whatever it is, let's say you were running a 10 megawatt operation and there's only 5 megawatts of wind running, you would be drawing another 5 megawatts from the network. And in cases where the wind farm was running at 30 megawatts, well, you'd be using 10 and 20 of it be sold to the grid. So we basically landed at the point of saying, depending on economics, which at the moment, those economics need to be in Australia, they need to be probably under 6 cents a kilowatt hour, I think, for mining operations. If you are in that environment, it actually makes sense to build one of these things at your site, whether it's you or outsourced or a third party or whatever it may be. Your decision is, do you build a battery or do you build, and look, the battery does other things. The battery helps the network in ways that obviously Bitcoin cannot. But I still think, from what we saw, it had definite benefits.
Yeah. It's a very interesting concept. And I could talk about this for hours, but we do have to wrap up soon. So we'll give you the 5-minute warning.
Okay.
But that concept is fascinating, that Bitcoin acts as a battery that can store the value of your energy over time. It's that salability over time that Saifedean talks about. You're seeing that kind of play out in the real world, and that's fascinating. So and it works quite well for energy that's trapped, where you can't get out to the grid for whatever reason. And we've got that in Australia as well, where there are limits on grid connections, especially in certain areas where there's, say, too many wind farms or whatever the physical constraint might be. If there's energy like that, then it can be captured rather than wasted. I think you told me as well about a situation with gas flaring, where you might actually be better off using it for an on-site Bitcoin miner rather than flaring.
And there's quite a lot of those around Asia too, still Southeast Asia. But the ones that stand out are the ones in the US that are the sort of stranded gas plants that are flaring gas anyway, because in the US they obviously got many years of that oversupplied gas because of fracking. Instead of flaring, and obviously you're still going to have particles being released when you're flaring off the gas. It can just be useful for I've heard I've heard stories where the gas producer was actually paying people to take the gas because that's actually cheaper than the environmental, having to offset certificates and things like that. So look, I mean, I think if you're going to, in that case, it doesn't really make sense for you to connect it to a battery because, well, there's no one who really needs it, in that particular case. I mean, there are a few sites in Australia that are very remote, that are sort of grids unto their own, servicing small communities, but that have, from the power source that they have, the power source is able to generate well in excess of what the demand is in that area. So we've looked at those also. The problem that you have there is connectivity. So we even investigated things like using Starlink for the connectivity. So it's still a maybe. So I think there are a lot of sites like that out there. I mean, Australia, sometimes you challenge with temperature just in general, because if you're in a place that gets to 40 degrees Celsius and you got a 40-foot container made of steel, there's a lot more energy required. What we looked at there was immersion, which also works.
And also distance, just such sheer enormous amounts of distance between communities that you can't just throw a wire over the fence and connect communities.
No.
And you have losses along the line anyway, even if you were to make a long distance one. So it may not be economical.
Absolutely.
But all right, I think we'll end it there. There's probably a lot to talk about and plenty, that we can discuss. But I think that's enough for this session. Thank you very much for coming on. Nice to meet you. Some great, and likewise, and some great takeouts for me and hopefully for our audience. So if our audience likes, please give us a like on YouTube and follow us on Twitter and our website, stormrake.com. But thank you very much for the session, Gary. All the best. And hopefully we'll have you on.
No problems. Thank you very much.
Cheers.
Nice to meet you, Michael. Take care.
Thank you.